Hello class. So this week I'm just going to present the presentation to you. So last week I kind of went through how to make the presentation. So for this week I deleted all of the red type, which were more instructions. And now I'm just going to blast through the presentation. Okay, so again, I want you to use this as a template for your own presentation. Both my PowerPoint, but also the actual presentation of me talking is sort of how you can pattern your presentation, but of course you've seen professors give lectures before, so I'm kind of just doing the same thing that I always do. Okay, so the article that I'm going to present to you today is called "The Influence of Resistance Training Frequency on Muscular Adaptations in Well-Trained Men." This article was written by Brad Schoenfeld, and some other researchers. And it was in the Journal of Strength and Conditioning Research. It came out in 2015. So, as you probably know, when you are designing a resistance training program, there are many variables which can be manipulated. Things such as intensity, volume, rest period length, etc. And there's a lot of evidence that suggests that changing those variables I mentioned in a certain way can have a positive impact on muscle growth. A less researched variable is the frequency. Not only does frequency refer to the number of days that you train per week, but also how many times would you train a given muscle group. Okay, there is speculation on how many times one should train a muscle group, but the evidence is not clear, and therefore no definite recommendation has been established. Now, the reason why this is important is because the goal of muscle hypertrophy, or anybody who trains for that, typically bodybuilders, is to train a muscle group to grow, right? And there's been this debated idea about how many times should you stimulate a muscle group in a weekly basis in order to promote growth. The typical way that bodybuilders have trained is using what is known as a split routine, okay? So in a split routine, essentially on a given day, the trainee would just train 2 to 4 muscle groups on that day. And then the next day they would train a different set of muscle groups, okay? Typically then each muscle group only gets trained 1 time per week. So that would be sort of classified as infrequent training. Now, we should say though that usually, as we see in this bullet point here, even though you're only training the muscle group 1 day a week, the day that you do train the muscle group, you're going to do a lot of exercises, 3 to 4 exercises for that muscle group. So you're still getting a pretty big stimulus for that muscle group on that day. The difference is you're only training a muscle group 1 day per week, okay? It is thought that that high training volume that the muscle group is exposed to on that single day of training is a very powerful growth stimulus. And the reason why that is considered to be true is because it has been documented that in order to make a muscle grow, you have to have a very high volume of training on that muscle group, okay? So in a survey, as I mentioned earlier, this was found to be the most typical training routine that a bodybuilder uses, and that is training each muscle group once per week. Now, on the other hand, another way to train is what is known as total body routines. Okay, so total body training is on a given day, you're going to train every muscle group. And then the next day that you train, you're going to train every muscle group again. So clearly, if you're training every muscle group in one session, you're not going to be able to do as many exercises for a given muscle group per session. Okay, so that's kind of the trade-off. Do you put all of the muscle group training on 1 day, or do you spread it out and train more frequently throughout the course of the week? That is less commonly used with bodybuilders, but is commonly used with weightlifters, powerlifters, and I would say most general fitness enthusiasts. Athletes often train that way as well. So it's really just bodybuilders that have typically gravitated toward this split training regimen. So there is some previous research that has looked into this, not very much, but I have 2 studies here that the article has shared. The first one was done by the same researchers, Schoenfeld et al. And what they found was that there was no difference in the muscle hypertrophy between a split and a total body routine. Okay. Now, they identified after their study was over that there were a couple key limitations that they identified that might have influenced the results in a certain way. Those being that the way that they loaded or the intensity that they used, as well as the rest periods, might have interfered with the results a little bit. So in this study that we're going to look at, they attempted to fix that problem. Okay. Secondly, there was another study, McCluster et al. They actually found that greater frequency promoted greater muscular adaptations. Again, though, this study had a limitation in that they did not directly measure muscle growth. Instead, they indirectly measured muscle growth by looking at body fat reductions and sort of assumed that if body fat was reduced, the muscle grew. That is not safe to assume necessarily. Okay. And then they also had sort of a lower total volume compared to the volumes that are typically used by bodybuilders. Okay, so the purpose of this study is to investigate the effects of either using a split routine where each muscle group is trained once per week, or a total body routine where a muscle group is trained 3 times per week on the muscular adaptations in well-trained men. Now, you do notice a word here in parentheses, and this is volume equated. So it's important to know that both groups use the same volume of training, and we'll see sort of how they arrange that differently within the groups here momentarily. So let's talk about the methods. So what did the subjects actually do? What did the researchers do to carry out this study? They randomly assigned the subjects into 2 groups. Okay, one group was called the split group. They had 10 individuals, okay? And the other group also had 10, and they were called the total body group. So the split group, their sort of general program design that they were going to complete was that they would do multiple exercises per muscle group, basically 2 to 3 muscle groups per session, okay? The total body group would do 1 exercise per muscle group, and they would train every muscle group per session. All other training variables were held constant, which means the intensity, the rest period, the overall volume, as we said, is going to stay the same. What really changed is sort of the way that the muscle groups were structured in terms of were they all trained in one day or they spread out across an entire week. Okay, this particular study lasted for 8 weeks. Okay, they did pre and post testing. So what they were looking at really was how the treatments affected muscular strength and muscular hypertrophy. So they did pre and post testing for strength, as well as the level of muscle mass in the forearm flexors and extensors, so the bicep and the tricep, and then in one of the quadricep muscles, specifically the vastus lateralis. Here's a breakdown of the subjects. So they had 20 male volunteers recruited from the university population. The subject age range was 19 to 29 years, so kind of in a typical college age range, maybe a little bit higher than the average college student. But maybe they had some graduate students in it as well. These subjects were all classified as being well-trained, and they defined that by saying these subjects had been training for at least 1 year, okay? And they had been training 3 times a week during that year. So they have experienced some adaptation, they had some baseline strength levels, and they had experienced lifting. That was a key thing here, okay? And you see their mean experience, average experience was 4.5 years, plus or minus 3.1 years. All the subjects were competent and regularly performed the back squat and the bench press, which is important because those are the 2 variables that they were tested on. And all were free of any injury and illegal drug use during the study as well. So the training protocol, I'm going to go into a little bit more detail on this. Basically, they selected 21 exercises, and both groups did the same 21 exercises. The key was how they were arranged per day. I have a chart on the next slide that shows this in detail. All of the training was volume equated, which means, and I'll explain this again on the next slide, but the split group might have done 3 chest exercises on one day, where the total body group did the same 3 chest exercises. They just did them on 3 separate days. Okay. So again, the volume overall throughout the week was exactly the same for both groups. What was different was how it was shuffled between the days. Okay. So both groups did 3 sessions, performed on non-consecutive days. So maybe like a Monday, Wednesday, Friday. As far as the set and rep scheme, we were looking at 8 to 12 reps per set, okay, all performed to momentary concentric failure. So basically, the goal with each set was to reach muscular failure somewhere in the 8 to 12 rep range, and when they were able to complete 12 reps successfully, they would increase the load slightly for the next set or the next training session. Okay, so they did advance their load based upon their ability to complete 12 reps without failure in a given set. As far as rest period, it was kept consistent in both groups at 90 seconds between sets. They did control the velocity of the contraction, so the concentric phase was done in a controlled fashion, which means as fast as possible but under control. And the eccentric phase, which is the lowering of the weight, was done in a 2-second. So imagine if they were doing the bench press, they would be 1, 2. So they were not lowering it rapidly, they were lowering it in a slow controlled fashion in a 2-second tempo. Okay. Every session was supervised by research assistants, which means the subjects were not in the gym by themselves, but it was supervised by the staff of the facility that the study was conducted in. Now, to get a more detailed look at the training protocol, here it is. Sorry that it's a little bit blurry, but I did have to do a screenshot to get this in here. So at the top, we have the split group. At the bottom, we have the total. Then we have their days. So notice, kind of like I was saying, on the split group, they did 3 chest exercises all on the same day. So 3 sets of bench press, 3 sets of incline, 3 sets of the hammer chest press. The total body group did those same 3 exercises. They just did them on separate days. So notice if we go down, they did the bench press on day 1, the incline press on day 2, the hammer chest press on day 3. To pick another one, the split group did squat, leg press, and leg extension on the same day. The total body had squat on day 1, leg press on day 2, leg extension on day 3, right? So again, everything that is shown up here is listed down here as well. It's just organized in a different way. So that's an important thing, because in order to really isolate frequency the best as possible, the subjects had to do the same volume. If one group was doing a greater volume than the other group, then that group would have better adaptation. So in order to really isolate the frequency variable, everything else had to be basically exactly the same. Okay. Lastly here, a few other things to mention as far as the testing, pre and post measurements. What they did is, in order to determine the training loads, they did a 10 rep max for each exercise in order to determine the load that the subjects started at on their first sessions. And again, they advanced their load once they were able to complete 12 reps without experiencing any failure. As far as the pre and post testing, they did a 1 rep max in the squat and the bench press, pre and post, to assess for gains in strength. And they assessed hypertrophy by measuring muscle thickness using ultrasound imaging, in those 3 muscle groups that we mentioned earlier: forearm flexors, biceps, forearm extensors, triceps, and the vastus lateralis, one of the quad muscles. As nutrition will affect training results, they did have to control for nutrition somewhat. Okay, usually nutrition is like the biggest confounding factor in exercise studies. So they did their best to control this. And what they did is they first of all asked the subjects to keep eating the same thing they had been eating before. If the subjects changed their diet when they started the study, that can be responsible for the changes that they found. So they told everybody to keep eating the same stuff you've been eating this entire time. Okay. In order to track that, they asked all of the subjects to keep a food diary on a daily basis using MyFitnessPal. They did add one thing to their diets, but again, Every subject in the study got this, and that was that each subject was provided a sort of a post-workout shake containing 24 grams of protein and 1 gram of carbohydrate that they were given after their workout, and they were expected to consume it within a certain time period following the workout. Okay. Lastly, then, they did the statistical analysis to see what kind of changes were produced using descriptive statistics. So let's take a look at what they found, the results. So it is common that not all subjects will finish the study. In this study, they had 19 out of 20 finish. That is a really good percentage. Okay. Of those 19, there were a few sessions that were missed, but you see that the compliance rate of the sessions was very, very high. So 97% of the total body sessions were completed. 98% of the split sessions were completed. You know, presumably maybe one of the subjects had to miss a workout because they were sick or, you know, something like that probably popped up. That's common. They analyzed the food journals, and they found no significant differences in any of the dietary measures. That's good. Okay. And then there was no difference in the weekly training volumes between the groups, and that was due to the fact of the way that they organized the workouts. Okay. So therefore, we feel pretty good about saying that any results that we found in strength and hypertrophy were due to the frequency changes. So let's take a look at what we found. So muscle thickness first. Were there any significant changes in hypertrophy? What they found was both groups saw increases in muscle thickness in all 3 of the muscle groups. However, only the total group had a significant difference in gains in the forearm flexors compared to the split group. So, let me rephrase that. Both groups saw increases in their forearm flexor muscle thickness, but the total group increased significantly more than the split group. Okay. As far as strength goes, both increased their strength significantly, but there was no significant difference found between the groups. Okay. So just looking at the results, looking at the data, the numbers alone, it looks like the total body protocol produced at least one significant improvement over the split. However, we did measure roughly 5 variables here, and only one of them produced a significant difference versus total being better than the split, right? So let's discuss, what that means, okay? So, based upon the results that we just saw, they did find that there is a benefit to training muscle groups more frequently per week, especially when the training is volume equated, okay? Even though I said there was only a significant difference in one of the muscle groups, there was a difference in all of them, okay? But only one of them, the forearm flexors, reached statistical significance, which means it kind of got to a certain height that we wanted it to, but the other 2 were maybe, they increased, but just not to that height, okay? So if we look at that, we could still say that the total body protocol did seem to support larger rates of muscle growth than the split routine, okay? And the theory that the authors propose to explain this is listed in this bullet point here, right? So it's been found that muscle protein synthesis will stay elevated for up to 48 hours post-workout. Now, if you're the split group and you're only training a muscle group 1 day per week, let's say you're training chest on Monday, well, the muscle protein synthesis in the chest musculature stays elevated until Wednesday, then it drops down for the rest of the week, doesn't get jumped back up again until the following Monday. On the other hand, the total body group, train chest Monday, stays elevated. By the time they get to Wednesday, it starts to come down. Well, guess what? They're training chest again Wednesday, so it's back up. As they go, Thursday, starts to dip down on Friday, but guess what? They're training again, so it goes back up. So what they're saying is that this more frequent training keeps protein synthesis elevated throughout the course of the whole week versus only having it spiked up high the first couple days of the week, okay? Hope that makes sense. Now, limitations, okay? Those conclusions sound awesome. Makes you want to go out and do total body training. However, there are some things that the authors admitted may have influenced the results a little bit. So let's take a look at these. They have basically 5 items here. First of all, the first few are not as important, but they thought that the study might have been a little bit too short, that if the study was longer, say 12 weeks, the results could have been much different, okay? They also thought that the sample size was smaller, so 20 people. That could have affected the statistical power. Maybe there could have been more or less significance if the sample size was bigger. However, in a study such as this, 20 people is about the average number that you have. It's hard to get big numbers of people to do exercise interventions. It's just a lot to manage. A lot of people power is required to manage something like that. So the more people you have, the bigger of a production it becomes. So 20 is a pretty average number, to be honest with you. Okay. Another one, they identified that where they measured muscle thickness could have influenced the results. That if they measured the muscle thickness in a different part of the muscle, that could have changed it. Again, that one's probably not as important either. Another one, and this is common to all studies, is that they used a very specific population. Resistance-trained younger men, okay? We can really only apply the results of this study to that specific population, right? If we had a group of elderly females who were untrained, the results could be very, very different, right? So when you're interpreting research, you always need to look at and admit that these results only apply to the population that it was carried out on, okay? Younger men usually, not younger men, younger people can usually tolerate higher volumes of exercise. As people get older, their tolerance for exercise tends to go down a little bit, so the high volume training might have produced more injuries in that population, okay? Now, perhaps the most important limitation I have in bold, that 16 of the 19 subjects were doing split training before the study, okay? So what does that mean? Why is that important? Well, for half of the subjects, they just continued doing what they had already been doing, okay? Where the other half of the subjects, they started doing a completely different style of training, okay? As you probably remember from other classes, in order to continue to promote adaptation, you have to constantly manipulate or change the stimulus that you're exposing your body to. If you keep doing the same thing all the time, your body's going to eventually get used to it and it's not going to adapt anymore, or the rate of adaptation is going to slow down a lot. So the theory then is that the split training group, because they kept doing what they were doing, the results were not as large, okay? On the other hand, because the total body group switched what they had been doing to something new, that sort of jump-started their progress, and that then produced these larger results compared to the split group, okay? That alone is a pretty important finding, right? So, that knowledge, even though it sort of undercuts the results of the study, that alone is also a very, very important finding, okay? And that leads us then to the practical application of this particular study, okay? This study shows that frequency can produce, manipulating frequency can produce a novel training benefit, okay? But that limitation actually suggests perhaps the biggest practical application, and that is that frequency should be manipulated and changed just like every other variable, right? So we're going to constantly change volume, intensity, rest period. We should also change frequency. That's just another variable that we can manipulate. So what that might mean is what I say in this bullet point here, is that maybe you do, 2 to 3 months of a split training routine. Then you switch and do 8 to 12 weeks of a total body, right? And then maybe you switch back to split, and then maybe you figure out something else to do for the next quarter of the year, right? It's that manipulation of the variables that really promotes the best progress and the biggest improvements in fitness, etc. So again, the conclusion is we can't say that one frequency is better than the other. What we can say is that changing the frequency periodically, that may produce the largest benefit in terms of improvements in strength, muscle hypertrophy, aerobic fitness, which was not studied in this, but it would apply to that as well. Okay, so that is the end of the slideshow. I hope that you found this article to be interesting, and I look forward to checking out your presentations. Take care.